Hi everyone, and this is my 8th video about the natural science physical interview. And today we are focusing on our completely easy problem, but with some curiosity. Okay, so in a physics stunt, two balls with equal density. We have this is R and this is R. Capital with place with the center of the larger one at the middle of the card of mass m, length, the mass of the smaller ball, and we have the made to roll so without slipping in such a way that the larger ball rests on the card and a straight line connecting their centers remaining at a constant angle. The card is pulled by a horizontal force in the direction shown in the figure. So we need to calculate about the F. So we're going to draw all the forces out. I'm going to draw a bigger scaled circle. This is okay. It is very clear that we can think about that. Here we have a reaction force, and here we have a friction force, and the contact of the two circles, we will transfer it into two perpendicular normal forces. We have N1 and N2. So now we will set up our equations. So first is the kinetic ones. So in order that the straight line remains an angle, it cannot have relative displacement. So this point must not be rotated. So as the balls are rolling without slipping, we have capital R times let's assume that this ball has acceleration of a2 and this has a1. This is also a1. This we have the beta 2, the angular acceleration, and this is beta 1. So r times beta 2 equals a2 minus a1. This is very clearly. And r times beta 2 equals r times beta 1. This is because this point cannot be moving around. So and we have r equals to r. So alpha 1 beta 1 equals to 2 beta 2 equals this a2 minus a1. And next we'll calculate about the moment and the momentum and the energy. So the moment of the inertia of the smaller ball would be I1. This is I2. So I1 equals to this. You have known that. And I2 have the mass will be 8m since the radius is twice, and r will be 2r squared, and we have this. So we will write about the dynamical equations of the motion. The first is F. Here we have an F minus F friction equals to m times a2. So this is the card, and this is the horizontal way, and next we will write the vertical ones. We have 8m times g plus n1 equals n. This is for the second ball, and we also have mg equals to n1. This is for the first ball and the second ball. And next we'll write the horizontal motion of the second ball. That is F friction minus N2 equals 8m times A1. And the first ball, we have N2 equals MA1. So, okay, now we have write about the forces. Next, we'll write about the moment. So, the first one, N1 R cosine phi minus N2 R sine phi equals this. This is for the smaller circle, and so this is the first ball. Next, we have the second ball. 2r times this is the capital R friction plus this sine phi 2r and r2 minus sorry, there's a right. So from these equations, two equations or a lot of equations, we can actually calculate F. But I think the calculation will be too much that the officer would not ask you to do that. 79 newtons, and the acceleration of the balls relative to the cart, which will be how much time it eclipse before the balls fall off the cart. So we need to calculate the relative acceleration. Delta A equals A2 minus A1 equals to something, and we use T equals to L over delta A. So it is 0.55 seconds. This is actually not a very hard question. You can also see it in some step, 6-term examination paper, and I think the difficulty actually matches the step exam. So although there's a lot of forces, but it is all fundamental ones. And because there are no slipping, you don't have to consider about the relative friction between the balls, and it actually helps you to deal with the problem better, since that will be very difficult because you have to calculate about the angles, right? And you have a differential equation and you have to solve that. So it is all for this problem, and I hope to see you next time.